folks. I'm here from Microsoft, the Azure Functions team. I'm Donna, and this is Chris. And we were inspired by this beautiful theater. So we're going to do something a little different for this presentation. We're going to put on a short play called A Day in the Life of an Azure Serverless Developer, starring Chris Anderson as the developer, with narration by Donna Malayeri. In this dramatic performance, you will experience the emotional ups and downs as we find a bug in production, fix it locally, deploy it to stage, and then use continuous integration to push it to production. We're going to be looking at the inner loop, which is when you're developing on your local machine, as well as the outer loop, when you're interacting with Azure resources. And you'll see just how powerful Azure Functions is. So, for the backstory, we're working on a popular and surprisingly business-critical website that generates trading cards from people's photos. The way it works is you upload an image, and based on your emotion, it gives you one of 4 cards using Microsoft's Cognitive Services APIs to detect the emotion of your face. Now, when our story begins, the architecture, of course, the obligatory architecture slide. At a high level, we're hosting the site in a single-page app that's hosted on Azure Storage, and we're triggering an Azure function when it sees a new blob in storage. So when our story begins, Chris gets a bug report from his manager, and it has the typical level of detail that he's come to expect from users. Chris, so there's these customers, they're complaining, and they say that when they upload an image, they get a card, but it has no title. And I don't have a repro, but can you fix it right away? Okay, thanks, bye. Now, despite the vague bug report and lack of repro, Chris is not worried, because Chris is armed with Azure Application Insights, which will give him rich telemetry and logging. With just one line of code in his Azure function, he's outputted custom telemetry that he can now query. The key thing is, he did not set up any kind of log parsing or indexing. Application Insights is optimized to give you fast queries for the most recent results. So when we scroll down here into the file name, we can see that there's these photos that are being uploaded with a file name of Stevie B, but yet the card title is blank. So that looks a little suspicious. Let's add a query clause here to filter just to those queries. Notice the IntelliSense in this web editor. It knows all about the schema, so it gives you a super productive experience as you're monitoring. So now, once we do this filter, we'll see that there are actually quite a few incoming cards that have some kind of problem here. So now Chris has an idea of what kind of file name triggers this issue. So he's going to go to his local machine and create a file with that same file name. In fact, we know there's a very famous Stevie B on the internet, and so Chris has chosen this beautiful photo to repro this issue locally. And so now he's running it locally, and once it uploads to Azure, you can see that it actually is processing these images here with the Azure Functions CLI. Let me point out, actually, let's go back to look at the URL. We're running on localhost. This SPA is writing to Azure Storage. The function is triggering locally off of that event in Azure Storage. This is super productive. No other cloud platform offers this degree of hybrid debugging. So now, what Chris is going to do in Visual Studio is set a breakpoint. Now, earlier you saw Visual Studio Code in JavaScript, so now for our great C# developers in the audience, we're going to show you Visual Studio. Don't worry, if you're a JavaScript developer, just squint. Pretend it's JavaScript code and Visual Studio Code. You literally get the exact same feature set. So Chris has a breakpoint now. He's going to run the function again, and we're going to see that breakpoint hit in Visual Studio. And again, we're triggering off of this live event in Azure, which is the key. You don't have to mock up your code. You don't have to write shims. You don't have to do any of that. You just run your same exact code off of those Azure resources. Because as we all know, when we test our data locally, we don't have any bugs. But when we get real customer input, that's where the bugs creep in. So I think we're having an issue with the connection speed, although now he's restarted the host. And also, notice the beautiful ASCII art. I want to point that out. I helped add that feature, so I'm very proud of that. And so now the debugger is listening, and we will, if the internet gods bless us, we will hit a breakpoint. We're not hitting a breakpoint.
It's not picking up the files. We just move on.
All right. Well, I promise you, I have videos on the internet that show this breakpoint being hit with a similar example. But what's going to happen is basically any Azure resources you're interacting with, you get to write that exact same code locally. So what Chris would have done if he had hit the breakpoint was he would have dug into the code, and he notices something a little suspicious here in the tuple, in the get name and title method where he's returning a tuple. If there is no dash in the file name, because it expects a dash with the name and the title of the person, it's just throwing away all that data. So instead, he's going to return the file name. Now, again, he's going to run this locally and test his fix. So notice how fast of an experience this is. And also, notice in that command prompts there, the script just changed and it reloaded. No need to stop the functions host and restart or recompile. It all just works really seamlessly, just like if you're in the portal. So now let's go back to the SPA that's on the local machine and upload a photo with the same type of file name. And we'll see, in fact, actually, it's working there on the left. We have a title for that coder card, which we'll do it again, just so you know that we're not lying. And also, this graphic is beautiful. This is all Chris is doing. If I ever meet Steve Ballmer, I'm going to ask him to just say those 3 words and record him, so then we can make it a video instead of just a GIF. And there we go. We have his title in the GIF. So now we have fixed the bug, but we're not done. We need to deploy this to production, but we want to do this safely. We can't just willy-nilly deploy to prod, even though I'm sure we've all done it, and we've all probably regretted it. What we're going to do is follow a safer deployment practice. What Chris is going to do is commit his changes into GitHub. We have a stage environment where we have set up continuous integration and deployment. Oh, sorry, one step before that. He tested it on his local machine. Now he wants to publish it to his dev environment in Azure. So what he's going to do is use the Azure Functions CLI, the same tool that runs the functions runtime locally, also lets you publish. And notice how he's publishing to his own production, his own instance in Azure. So he's not going to interfere with any other commits from other devs. So we're going to push those changes with just one line of code. And once that's done, we're going to go to stage. And again, verify that this bug is fixed. Dev. We have literally 4 environments in this demo, so I'm getting them all mixed up. But you can see from the title of the, we made a lot of big changes between our different environments. We changed the title of the page to say that it's dev. So now Chris will upload our same beautiful photo to dev. And if you look in the portal, you will see that change got pushed through successfully. So if Chris goes to that method that had the tuple, and you can see here that file name change did make it in. Awesome. So we know the code is there. We just test it on dev, and we will see that the title will show up. And we just have to watch it because that'll make it go faster. And I think we did notice it being a little slow. Oh, there we go. And it has the title. Yay! Okay. So now Chris knows that it works on his local machine. He knows it works on his dev instance in Azure. The next step is that he should commit it. And we have a stage environment where all the devs are committing their changes. And we'll have some tests that we run. For instance, we have vendors that do testing or automated testing. In fact, on the Azure Functions team, this is what we do. We have a stage environment for the Azure Functions portal, and we have nightly tests that are done with vendors as well as automated tests. And that's how we know that our changes are safe to push out to all of our customers. So now Chris has pushed this to GitHub, and if we go into the Azure Portal, he's adding it to GitHub, and he will then push to origin. And if he goes to the Azure portal, we'll see our config. Azure offers built-in continuous integration and deployment with a variety of popular source control management services, such as GitHub, Visual Studio Team Services, Bitbucket, you name it. You can also wire up your own build and release pipeline, like TeamCity or VSTS. But this is a really streamlined way to do this. Notice here how we have the pending change that's coming in from GitHub right in the current time. So that change is getting picked up and being pushed into stage. Now that the file name is fixed, and you can see that we have this beautiful commit history, we can see exactly what's being pushed to stage continuously. We're going to go to our stage environment. Finally, I keep talking about stage. I'm so excited about stage. Now, we will once again upload this beautiful photo, and we will wait with eager excitement and anticipation as we see this photo being uploaded. And come on, internet, you can do it. Yes! And the photo that is there, and the title shows up. So now we know that even though everyone's been making all these changes in stage, the code is safe. Now, the final step is pushing to production. Now, almost every development team I've spoken to does not automatically push to production. They have some kind of manual step with human intervention. For instance, on my team, our dev leads will look at the list of changes and we'll see if there's anything risky and see if we need additional test coverage. So now, imagine that Chris has the role of the dev lead and is like, yes, this is an awesome change. We got to fix this right away. So he pushes the manual sync button and syncs from GitHub as well and builds on the server. And then we will see that that change has gone into prod. And we can see now it's building. And in just a couple of minutes, we will have our change live in production and we can test it. Yay, now it's in production. All right, now you can see this is the real site because the title just says Coder Cards instead of Coder Cards Dev. Because we had really good file name differences there, title differences. Now we're going to upload a bunch of photos, and we're going to see that all of these photos, despite their weird file names, have been successfully converted using our business-critical service of Coder Cards. Just to summarize, this is the deployment process that I showed. Chris was using the Azure Functions CLI as well as Git commit to push his changes to his dev branch. When he did a Git commit, it went to stage, as well as other changes from his team. And then we did a manual deployment to production. So now you can see how Azure Functions tools help you with the full DevOps lifecycle. So, serverless devs need powerful tools. If you think about it, if we're not thinking about servers, we don't want to be thinking about our tools either. We want great tools so that we can debug locally, we can run locally, we can push to production with confidence. And we can use features like continuous integration to ensure that all of our tests are running and we're not randomly pushing random stuff to our customers because, if we just push to prod, bad things would happen. So you can learn more and try Azure Functions for free. All you need to do is sign in with a GitHub login, and you get a 1-hour site where you can try it out. The source for this wonderful demo is also available on GitHub, so you can run your own card generator. Thank you very much.